This assignment has you look at z-scores, which is a type of standardized score which is very common in the field of statistics. Z-score basically is a number which tells you for a particular value how many standard deviation it lies above or below the mean for that distribution. It's called a standardized score because you could take 5 different distributions, but if you had a value in each one of those 5 different distributions that lied 1 standard deviation above the mean, that always means that it has a certain probability of a value exceeding that, and that probability would always be the same. So anyway, the first thing I want to do is do some summary statistics here. So as we did in Module 1, we'll do the data analysis, do descriptive statistics, make sure your 15 values are highlighted, summary statistics clicked on, and there you go. You've got your summary statistics there. I'm going to do a little z-score formula here, which will just be the value x minus the mean value. I'm going to put some dollar signs around here just because that locks down that value when you try to copy it. Divide it by the standard deviation. Again, I'm going to put some dollar signs around that because that locks that value down when you try to copy it. So anyway, there's the z-score for that. I can copy this value on down. Now I've got z-scores for all those things. The other part of this said, are there any values to standard deviations above or below? Again, you can just do a little formula for that. Mean value plus, 2 times standard deviation, okay? And then, similarly, mean value minus 2 times standard deviation. So you can just look at your values and you could say, hey, which ones are above this? And there's only one here that's above it. That. And how many are below it? And there's only one below it. Alright, so 2 values above it. There are no values, 3 standard deviations above or below it. So anyway, on this, one of the things that you are asked to do is take these values and figure out the probability of values existing above or below this. And this is fairly straightforward. You'd want to go to the z-table formula in your tables in your back of your book, which, and you could take any of these. These tables start on 281. But for instance, the first one there, which has a z-score of, 0.17, a negative 0.17. If you look on page 281, 0.17 would tell you that you have roughly 0.325, or about 43% above a chance of probability of having a value above that z-score. Now this, in your particular assignment, this is a negative 0.717. So you would have roughly about a 43% probability of a value occurring below that. Okay, so 0.17 or negative 0.17 is not too far away from the mean. If you were right at the mean, you'd have a 50% chance of a value occurring above or below it.